Okay, today I'm just gonna show how to use the debugging inside the FPGA. So here we have Vivado, and then we're gonna create a new project, which is gonna be from scratch. Just select some place to have your project. Here we're gonna call project ILA, and then here next, and the board that I'm using is a Chinese board from Mer, is Z board, Z-turn, and this is it. And then this is the normal procedure to create a new project from scratch. Some people can jump that, but then here we have the entire block, the entire project. So basically you just create a new block design. In this new block design, you're going to instantiate some zinc block. And then you will run block automation just to insert the memory and the IOs that are already presetted from the board, and that's your project. That's your main project. So we just save, and now we're gonna work with DMA, but with two components. Basically, we're gonna insert DMA, and this DMA we're gonna just make things simpler. It will work with scatter gather enable, but just to make it simpler, we disable this, because I presume this is the beginning of everybody. So okay, and then we just not to have some valid trigger, I just go here and I insert FIFO, stream data FIFO. So basically what's gonna happen is we're gonna run automation, all of them. Run automation again. And then the FIFO. And then the FIFO is basically just to have a valid trigger for our system. And then I just connect I'm gonna just do the project to make a better layout here, and then you just connect it. Instead of doing a loop back, you just do that. And then you connect the clock with the main clock, and the same to the reset. Just to make things more complete, it's not necessary, but would be nice in the future to have, you can enable the interrupts of your project. Basically you go to the interrupts, and then you just enable here, and then you have this port to communicate with your interrupts from your project, and then you just add concatenation block, and then you have this and then you can deliver the interrupts from your project here and here. So now is the key. Let's say this video is to show how to debug inside the FPGA, and one very special protocol that you're going to be using all the time is the XI stream, which basically is this bus here. All these buses in the FIFO and also in the DMA, everyone that ends with S, XI, it means is XI stream. So it's the simplest one and the fastest one for data transfer. So we're gonna Now insert ELMA system, which is the debugger. Basically what you're doing is you're instantiating some block inside the FPGA to communicate with your JTAG and send the information that you're gonna be checking or monitoring from your project to the external world. So basically this is the block. What I'm trying to say is your FPGA is gonna have some extra logic just for this debugger. This is gonna be like a mini server that is gonna be collecting the buses or the signals that you want to watch, and then it's gonna deliver to you in the Vivado. So because we're doing the slave and the master, we're gonna have two slots. And then in the slot 0, we're gonna change here for our XIM stream, which is basically XI stream, XI master, which is here, XI RTL. The same to the slot 1. Also XI. I presume the other one is telemetry, TLM, but I don't know exactly. So yeah, you just change that, and then you have two slots, and then let's say, because when it's XI string, there is no double channel, it's just single channel from master to slave always. So basically the master is always write to the slave, and the slave is always receiving data to the master. That's why it's unidirectional. So that's why the first one for our FIFO, we're gonna check these two ports. We're gonna check when the FIFO gets data and when the FIFO transmits the data. So he gets the data from the slave channel. Basically, the DMA is gonna write the data to the FIFO and then process, and then the FIFO send back to the DMA via its master channel. So the 0 is slot. We're gonna check the slave, because it means that we're gonna see on top the initial value or the start, and then you see on bottom of our oscilloscope the master, which is the second signal. Oops, not this one. Oops. Okay, let's just connect the clock, the reset as well, and then I'll just zoom in here just to get this port, and then monitor the master, and then this is it. So now we can continue with our project, and then the next step is to generate the wrapper, which is basically create HDL wrapper. Just leave Vivado do it to you. Yeah, so I was just trying to explain why I choose, the slave slot 0 and the master is slot 1, just to show the transmission and then the reception and then the transmission, or the read and then the write. Okay, you already create that, everything's sorted out. You can check if it's a valid project here. No errors, and then you go to the generate bit stream. Save. It's gonna take a little while. For this video, just to be fast, we can check our design using bare metal or no operational system, just to be faster, because it's a transmission, is a memory transfer. Data is going to be transferred from the zinc to the FPGA and then back. But then no operational system, we're going to be using the SDK and the examples that Xilinx made available to you. So basically you have a series of DMA transfer that it can be done using interruption, or you can use pooling. You can use pooling. You can transfer different size of data. Yeah, so it's actually very easy. I'm just gonna wait for the project to run. Even having a good computer is kind of slow, so that's why the debugging sometimes is slow, because you change something and then you have to wait a long time until compile all the way to the bit stream. Yeah. So just reviewing again, we just add a DMA, and this DMA is in simple mode, so there's no scatter gather. Could have had with no problem, but I just think that the natural path is to start with the simplest one, which is simple path, and then scatter gather is still easy to use when you are in the standalone mode, but then would be a more advanced step. And then once that we add the XDMA, we add a little FIFO just to have these two channels separate, and then you can see the transmission between them, and then you can trigger valid signals. Because if it was a feedback here, it would not be easy to use some signals to trick, because they might be on all the time. So yeah. The other thing that I also did was to insert this concat, just to concatenate the interruptions. Yeah, it's because of I am recording this screen, I guess it's getting some extra slowly. Okay, I'm gonna pause here, and then we continue later. Bit string generated, no problem. So we just close here, and then you come here, and then we export our hardware for our new project. It's going to be a software project, and then we launch the SDK. From the launch SDK, we're gonna do the final test, but we actually gonna record, or we're gonna do the download of the bit stream in the FPGA via Vivado, because here is gonna be it's gonna show the screen of our virtual oscilloscope, showing the signals that we are watching from System ILA. So no problem. Here we see the SDK is initializing, and then we're gonna load some project from that Xilinx already delivered to you. Is examples. I'm gonna pause again, otherwise this video is gonna be too long and everything's taking time here. Okay, no need. Okay, things start failing. I feel embarrassed, but come on, SDK is not that heavy. Great boy. Okay, so here we just, having a new project, which is a new application project. We're just gonna call DMA single, and then we're gonna use the hello world as the base. As a project base. Some people, they really go first this hello world and then they go to the next project. Because I'm pretty confident about, I'm just gonna skip this step. But now we have to find the project that we want to use from Xilinx, which is basically in your Vivado installation directory, which is gonna go with some point in here. Jesus Christ, come on. No, I love Linux, but you see, nothing is perfect. Okay, come on, come on, come on. And then X, and then Vivado. Actually, I guess it's SDK 2008, and then it's data, and then embedded, and then third party, and then oops, I guess it's this one, drivers. And then here you can find many examples. We're gonna use XI DMA. In the XI DMA you have the examples. Take note of this path, and then for our case we're gonna have simple example pool, which I guess is the simplest possible. As you see, you have interruption, you have self-tests, which actually is a lot of things happening here. So just open this, take the code and pass to your hello world. It's supposed to work. Come on, come on, come on. And then just open another window. As you see, here is the code. I just select all of this, Ctrl C, and then you select all of this, Ctrl V, and then you save, and then recompile, and then everything's supposed to work. You can go through the code. You can change things like start value, the package length. It's already pre-compiled. So basically, before, instead of using this one to program the FPGA, I prefer to go back to your original project, and then you do from here. Basically, you just open target. It's already pre-saved, my original project is gonna find it, connect to the server as explained, the JTAG, and then here you start seeing already our final destination, which basically is the live waveform that is going to come from your signals. But before that, you have to add the probes for the signal that you want. So basically here you already see the waveform, but what I did was I just downloaded the project using program device here, and then it's gonna capture to you the bit file in your debugger, in your probe, and then you just program it. Okay, no problem. And then here you're gonna have the signals that are gonna start live, but you have to select some. This one is not being used, so but you have to select some signals to use as a trigger. In my case, because we are using XI FIFO XI stream, so we're gonna be using the ready from the slave as one trigger. So basically you just come here and you add it, the ready from the slave, and also, and from the other side we're gonna be using valids from the master. This is all output signals from the FIFO, so it's not signals that come from outside. This way we can basically trigger when the FIFO gets ready. When it gets ready, he starts receiving data, and then he sets valid to transmit that data they just received. So here, so we just set as a normal oscilloscope, we just set the value for 1 and the same the value for 1, which means that when ready and valid are 1, we have the handshake and we have data transmission. And then it's supposed to just run the trigger, and then is waiting for the trigger. And then you trigger actually from the software, which is basically here. You just have to, I'm just gonna show here on the site. You just have to come to your previous project, come from the example, and run. And then you see the signals. Voila. Basically, you're gonna see you're gonna give a zoom in. Sorry. Come on. And then you can see all the signals that you just transmitted from your application. Oh, come on, come on. Yeah. One funny thing is the size. Actually, the transmission is gonna be being done in char, I guess, from the SDK. So he packs 4 chars into one int, and then when you open here, you are able to see the data in terms of, from, you can see then here, that's the first data that you transmitted, and that's the second one, because I started from C. When you come here, you're gonna see that the starting point of the start value is C. So C in binary, is 1100, right? And this is exactly what you see here, 1100 and 000. This is C, and the next is D. So we're going to be seeing here D, which is 1011 and all zeros, and then so on. Thank you very much. I hope it helped a little. Sorry for the confusion.